Hello everyone, thank you for watching this video in which I will answer a question regarding ACLs with Spring Security and the way to configure security at the domain level. So the question was about what is ACL, when do we use ACL, for example, together or without having also the endpoint based security. And basically the fact is that ACLs are pretty difficult, and they represent the most granular, from my point of view, the most granular way to apply security. It applies security at the record level or at the instance level of an object. We can call it more generally. Usually it applies to things that are stored in the database, so that's why I basically refer to the database. That's why the only and main implementation of ACL at the moment is the JDBC implementation. That means that the ACLs are managed in the database, and they usually refer to things that are stored in the database. But if you want to see them at the more general level, like a more general picture of them, they theoretically can be applied like just a set of access control entries that apply to each form of information that you manage inside your application. So we can simply call that it can be applied to any instance of information in the system. And that differs from the endpoint security in terms of when you apply security at the endpoint level, you are basically caring about the role or authorities of some authorized roles, and based on who has been authenticated, then you can authorize on accessing a specific endpoint, for example. And you basically do that by extending the configuration by extending web security configure adapter, and then you override the configure method, and you can specify there all the rules using the matchers. You can even do that by using the global method security based on roles, but that's only at the method level or at the action level. And that means that you don't care about the information that is delivered, so you don't grant or restrict the access based on what is the data that the endpoint or the method works with. And now if you use the access lists, you actually go much more deeper and more granular, and you can even specify the security rules on the domain level, on the instances themselves. It's pretty complicated and it's very complex in configuration. That's why I will try another approach in this video, and instead of writing directly the code, that's what I'm usually doing, and because it would probably take me a lot of time to do that, and then I would also miss part of the configuration because it's pretty complex and I don't remember it by heart. I have already created in this case a project, and I will try to explain it step by step and all the things that you need to know about ACLs. What are the ACLs? How do you apply them in a project, which are our basic implementations? It's actually one implementation, the basic implementation, the JDBC implementation provided by Spring Security, and which are the contracts that you could basically implement if you would like to create your own implementation, which I've never done that, and I don't know if I would recommend that, because as you will see, it would really be some work to do there. So and maybe you don't even need to do that. Maybe you will find that the default approach, the standard approach, it really fits for you as well. So I have created a database, and I have here a database in which the first table that I would like to show you is this simple product table. So this is basically the information that I will secure by the access lists. It's a very simple table defining a product that basically have a name and a price. And you can imagine that you could have multiple tables, and which are more complex in terms of relationships, in terms of more columns and so on. Doesn't matter. But for us, having the product table that we will try to secure is enough. So access lists means that I will actually tell Spring Security and my Spring application who is allowed to access product 1 in terms of reading or writing, who is allowed to access product 2 in terms of reading and writing, and so on. So I'm going to the deepest level of granularity where I can specify the security not on action, not on endpoint, not on method even, but at the model directly related to the piece of data, and where I can say who is able to read a specific instance of an object. That's the ACLs. And usually they are too complicated and too complex for most of the applications, but there are still applications in which you might find useful to have something like this. And that's where Spring Security even comes with these contracts predefined and an implementation that you can use. So this is what I want to secure, this information stored in the product table. But in order to do that, I had to define in the implementation for JDBC these 4 tables. And the 4 tables are used by the JDBC implementation of the ACLs, and I will go deep into this implementation right after I explain you which the tables are, and then I might come back to the tables to explain it properly. The ACL class table is a table in which you store the classes that are secured. In my case, this is the class, the entity class, because I have used JPA and Hibernate in the project that you will see next. And this is mapping the product table. That's why in the beginning I said applying at the model level doesn't necessarily mean that you store that in the database. It happens in most of the cases, it happens in most of the practical applications, but Spring Security doesn't doesn't couple to the database. So these ACLs couple to an instance of object, and that instance of object, you can imagine that it could even be a DTO, a data transfer object, that you work with a web service of some specific type, or with a message broker. In my case, I've chosen the easiest implementation. I have a JPA entity, and it maps the table in the database product that I have shown you. And then I have to record that. I have to tell Spring Security which are the types for which I will create ACLs. So I have added here a row in the ACL class, and I have of course an identifier, a primary key, and then I have the class, the only class in my case that will be secured by ACLs. And then we also need some users. So this SID, which is the security ID, has 3 columns. One is the primary key, don't care about it. The other 2 which are important are the principal type, is called principal, but it's basically the principal type. And then the SID, which is actually exactly the username or the name of the role. And the principal type tells you if it is an user or just a role that you secure. And that offers you the possibility to put the restriction based on a role, and then you can tell all the admins or all the managers can use this instance of the object. Or you can do it much more granular, where you say exactly which are the users, and then it can be John and Bill, and John and Bill can actually have in your application different roles. But you just tell in the ACL entries exactly who in terms of user can access that data. So this ACL SID table allows you to register which are the roles and the users to which you will add entries later. In my case, I want it to be the most specific and use directly the users. I could have used roles, and I could have only added one role that could have, for example, accessed in terms of reading all the instances. And I can use them mixed. I can have both users and roles, and the entries can even override one to the other. It's a lot of details here. I will go into this, but for the moment I just want you to understand what this table is. It stores the type of the principal, the type of the and the user that will access the entities, and the name. So it can be John, which is 1 means he's a user, and if it were 0, then the row would have to refer to a role, and it would be role admin or role manager. If you want to go not that deep and just add restrictions per user, you can just add use the same setup but add the restrictions per role, and then for a role the value here should be 0 in this case. And then we had the class, we had the user, and we have not the entry, sorry, the next one we should see is the object identity. We have the object identity, and the object identity represents the instances. How are the instances represented? They need to be one of the classes from the ACL class. In my case, it's very easy because I have only one, so this is the foreign key to the ACL class. One means product, which is my only one here. And then you have the object ID identity, which means the way or the identifier that is used to make the difference between two instances. In my case, again, it's very easy because I have chosen a very simple entity in the database. I can use the primary key. It can get more complicated if I don't have such a primary key or something like this. Then I should add one or do something to have one. But the ACLs need somehow to identify uniquely the objects. So 1 in my case is representing the record with the primary key 1 in the database, and 2 is the other one. So again, in my product table, that means the beer and the chocolate, 1 and 2. And then we have parent objects. I didn't go deeper with this example, but theoretically you can even have a parent of this object, and that happens in the situations in which you have, for example, an invoice and the invoice lines, and you have an invoice that has some restrictions, and you want the same restrictions to apply to the invoice lines as well, because you don't want somebody who doesn't have access to the invoice, that is the parent, to be also to have access to the invoice lines, for example. So it can go that deep, in which you can have relationships and use the relationships between the objects, and you just add the restrictions and you specify if the restrictions are or aren't inherited. And that's actually the last column here. You can see 0, it means that restrictions aren't inherited, but anyway, in my example here, 1, it wouldn't even make sense, because in order to be inherited you need to have a parent object. So if you have a parent object, then you can specify, I want to inherit the same rules applied for the parent to the children. Or maybe I can leave it 0 and I say I have a parent, but I don't want to inherit the rules. So depending on how you want to configure is very, very detailed. You can configure in details everything about this relationship. And then we have the owner of the object, which will be one of our owners. In our case, the owners, it's a foreign key to the SID here. So the one that we have already seen, where we define the principals, we define the users and the roles. And then having all this, so we have the classes used, we have the instances defined, and we have the users. Then we can go to the last table, that are the rules themselves, the entries. The entries are the rules. What would you like to specify regarding a specific instance in terms of a specific SID? So for example, here ID is just the primary key, again, don't mind it. But then I say the object identity 1, which is referring to this table object identity here, 1, is in terms of the user 1, which again is this user, so John. And you will see that to make it easier to read, I have only added rules for John here, so the other user here doesn't have any rule. That's why we will see that he isn't able to access anything. So we concentrate on John, and I have added some entries for John because we only have here 1, 1, 1, 1. All these 4 rules here are for John. And for John, I have added 2 rules that are for object 1, which is the beer. Yes. And object 2 is which is the chocolate. Okay, so these 2 rules, John in terms of beer and John in terms of chocolate. And then what do I say here? I specify the operation, which in the case of the default implementation that I'm using in the project, 1 refers to read and 2 refers to write. So that means that in this case, the user John is able to read but isn't able to write the object 1, but is able to both read and write, both read and write the object 2. And then we have the granting, because this is where I was referring. 1 is if you grant and 0 if you restrict. So that means 1, we grant permission to read, which is 1 is read. So we grant the permission to read to user 1 for object 1, and we do not grant, we restrict the permission to write, 2 is write, for user 1 and object 1. And then we both grant the permissions to read and write for user 1 to the second object. Beside this, which are the most important of the columns, so the object, the SID, which is, I said user, but you know that could be user or role, is the link to the SID here. We have the operation itself, 1 and 2, which means read and write. We have the granting, what you do, you authorize, or by contrary, you restrict. 0 is restrict, 1 is authorize. And then you also have the order in which they are applied. And the order is important because it might change the result. For example, you might have a rule where you specify that all the admins can access object 1 instead of John. John is an admin, but I will add a rule for that user so that he can't. So and then I have to be careful to put them in the correct order, because if I say first John can't access but all admins can, then John being an admin will be granted access. But if I do the other way around, I will say that the first rule is the admins can access the object, and then I will say John can't, then John will be restricted, all the other admins will have access to the rules. So you see, you can play a lot with these rules and do a lot of things. So that's the order is important sometimes, and that's why you have an order here. And then for the audit success and audit failure, fortunately these are only referring to the logging, and based on the fact that I have added 1, I have enabled both the success and the failure for all these objects. And you will see that in the logs in the console of my project when I will run the application. Usually you don't want this to be on, because then you would have a lot of loggings in a real application. So that's why you have them in the database, such that you will always keep them on 0, and then you will activate them only when you have a problem and you want to see why some user has some restriction. you can audit the you can change the value to be able to audit only for a specific instance, such that you don't flood the logs with absolutely everything and all the rules that are interpreted. You see that for this very small amount of information in terms of security and access, I have already added 4 rules, so you can imagine how many rules could you actually have in an application. Of course, remember that you don't necessarily need to add them for all the users. You can use roles for that, and usually it's enough just to say the admin can do something and the other kind of user can do something else. Now that we have seen these entities, I will go to the project, and in terms of project, I will start with the repository, because this is where I will basically apply. In my case, it is not necessarily that I can apply this in any kind of in any situation, like on any method. I can apply it at the service level as well. I can even apply it at the endpoint level if I want, but in my case it was just easier to put this in the repository, where I have only added one method, is the find all. And then I've added this method here in my product repository because I wanted to annotate it with this global method annotation, which is the post filter. The post filter, which is one of the 4 pre-post annotations. The other ones are the pre-filter, pre-authorize, and the post-authorize. These are the most used together with the ACLs as well. So for example, post filter here receives an expression in terms of Spring expression language, and based on the expression provided, it refers to what happens with the return type, with the returned value actually of the method itself. So you can see here that find all, of course, returns a list of products. In my case, it will, you already know, always return a list of all the products in this case. But by adding the post filter here with the has permission right, where the filter object is actually what is returned by the method, it will only allow to be returned, it will filter, and it will only leave in the result the objects for which the user that has accessed the method has the permission to write. And what does this mean? Going back to my configuration here, is that for my only user, for one that I will try to use in order to access these products, even if I have 2 products in the database, the beer and the chocolate, remember that user 1, for one of them is not able to write, which is the one is the beer, I think. So the beer cannot be written by the first user. So that means that this 0 here, which is unauthorizing the write permission for object 1. So that actually means that user 1 can't write the beer, and because write operation can't apply to beer, and my configuration here tells that the user logged in will only receive the objects for which it has the right permission, that in my case is only the chocolate. So chocolate, of course, it has the right permission to here. For the chocolate, which is object 2, it's granted, but for the object 1, which is the beer, is not granted. So even if the method finds all the products, they will be filtered based on this, and my user won't be able to see the beer because defined in my entries, they are not allowed to write the beers. So the beer will be filtered and only the chocolate will remain here automatically. And you can play with the global method security annotations, pre-authorized, offers you the possibility to specify something in regards to before calling the method. So can I do something if the user has or hasn't some permission before? Yes, I can, for example, unauthorize the call of the method if they don't have some kind of permission in my ACLs. The post authorization is where the method is allowed to be called, but based on the return type, you will then unauthorize, and then based on, of course, the ACLs, you can unauthorize the result to be sent. Or you can just use the pre-filter and post-filter to filter the parameters or the return type. The most visible from my point of view would be to simply filter the returned value to see that even if I call find all and I have two objects, my endpoint being called with the user that doesn't have the right permission on the beer will only receive the chocolate, because only the chocolate is allowed him to be written. That's the implementation here. And in order to be able to do this, okay, of course, I will drive you through all the application to see that it's not a big deal of everything else. It's just the product entity here, very, very simple. If you have followed my JPA videos or my other Spring videos, you already know what this is. And you know, that's a very, very basic entity here. I have an identity generation strategy for the ID, and then only the name and the price. And then I have a product controller that all it does, it directly injects the repository here for simplicity reasons, and the maps the all path with the get method and calls directly the find all method that we have previously analyzed. So exactly the one that you have seen here that has a post filter applied. So when you call this endpoint, it will call the method, the find all method, and then the post filter should apply the rule based on the access lists. That's the project. In theory, it's very, very easy, but it comes to be very, very difficult in terms of configuration. First of all, I have shown you the tables in which you have to always store and manage everything in terms of the access. So the rules themselves, which can be heavy depending on the size of your application. Even for a microservice, it can be heavy. And then it comes in terms of configuring itself. So here I've split it into two configuration classes to make it easier. In the user details config, I've just added the password encoder, very, very simple, just no op password encoder, and two users, John and Bill, with some passwords in memory. So just to take it out completely, and we don't mind. It's just a very, very dummy implementation where you have two users with the password 1 to 5 with the two authorities read and write, and that's everything that is managed by our user detail service. And the password encoder doesn't encode, it's just the no op password encoder, which is that password encoder that keeps the passwords in plain text. If you don't know what this is, you can go to my first video of Spring Security in the Spring Security playlist and take those videos there. They will help you understand the basic contracts in Spring Security. This is part of the basic contracts, so I won't explain them in this video. But if this is the first time you see Spring Security and you don't know what is the password encoder or the user details service or the user details manager, then you can just take them and take the videos there, and you will see them explained in a lot of details. I will now focus only on the ACLs. And then the big configuration that I put in the project config. There's a lot of configuration in terms of this simple, let's call JDBC access list implementation. So I will take it line by line to try to explain everything that's out of it. First of all, we have enabled the global method security, and the only thing that I have enabled is the pre-post enabled. This is important. By default is false, but I needed it on true because that's how I tell Spring Security that I have a post filter here. So whenever you use a post filter, pre-authorize or post authorize, you have to make sure that you tell Spring security that you want to use that, and this is how I do that. I enable the global method security, and especially I enable here the pre-post annotations. And then I have to tell Spring Security which where to take the expressions, how to understand this expression. This has permission here, where is this defined? And then how do I do that? Well, basically I need to define this method security expression handler. The method security expression handler will define for my pre-filter annotation how should be the expression interpreted. So what I do, I extend this class in order to be able to override this method from where I can return the instance of the method security expression handler that will be used by Spring Security. And then I define that in the context, so that's why I auto-wire it here. And somewhere at the end of my class, I've left the bean that actually defines it. So this bean is the method security expression handler. Inside I have its definition, then it is returned. It will be automatically placed in the context by Spring Security, and that is what I injected here, and then injected from here it is returned from my overridden method. And in order to be able to create this bean, you will see that I had actually to define an ACL, which is an access control list service. And this access control list service is one or maybe the basic of the contracts of the ACL framework. Let's call it the ACL framework. It's part of the Spring Security, but I will call it the ACL framework. And the ACL service, which is this contract somewhere here I have defined, let's take a look. It's just a contract defined in an interface that you could basically implement yourself. But mind that you will have to deal with these contracts, which will you will actually have some methods to implement here, so it's not that easy. I can't compare this, for example, with the way we understand the password encoder and the user detail service, the basic Spring Security contract. That's a lot more easier than what the ACL implementation is. So that's why I usually would recommend you to go to the default implementation that is provided to you, which is the JDBC, which is the one that uses the tables in the database, exactly what I have in my project here. Otherwise, you would have to implement all these contracts yourself. So we have the ACL service, which, how the name suggests, is the service that is used to manage the ACLs. An ACL, which is the access control list, is a group of permissions, and the permissions, if you remember from my table, they are abbreviated ACEs from the entries. So is the access control list entry or access control entry. And if you go to the service app basically manages the ACLs. So if you go in the ACL contract, which is another interface, you will see that always an ACL is a list of entries, and these are basically, in my case, in exactly the JDBC implementation, the records in this table, the access control list entry. So an ACL is a collection of entries related to a specific instance, which is the object identity. Object identity is the instance itself, and to the SID, which is the user or role in this case. Okay, you have then beside the ACL, you have the access control entry, which you will recognize to be basically the line in your in the table of entry. You have the permission, the user, the parent ACL, if it's granting or not granting. You have the object identity, which is the instance itself. It has to have an identifier. What we have discussed in my case is the primary key, because I use the product which is also a record in the database. So all these contracts together they form the framework of what we can call the ACL implementation for domain object security and Spring Security. But of course, you would basically rather go for the default implementation. So let's see in the default implementation. Then you can just try to see which are the implementations that you have, and you will see you have an JDBC ACL service, and one of the services here is the implementation that we are also using, and you can see it defines all the queries that you need in the database to work with those 4 tables, the ACL entry, ACL class. Maybe you wondered, where did I take the names from? So maybe you wondered, why did I call this table ACL entry? Where the way I'm working is I basically don't remember them by heart because I don't use them that often. But what I do is just go in the implementation of the class. So from the contract, I find the implementation, and then I go here and I find the name of the classes. This is the easiest for me. And then you can find all the structure here. You can just deduct the structure from the queries because you see the name of the table and the columns themselves. So this is how I'm doing in order to not need to remember all the time all the details about this. Basically, I am again not doing that this thing daily. So that's why, and it's as you can see, a very complex subject. Good. So we need this ACL service. That's why we have created this ACL service. And if you see here, this is exactly the class where I have driven you. So I'm using the JDBC mutable ACL service, the one that I have shown you with all the queries. And in order to be able to create the JDBC mutable ACL service, then I of course need a data source. Guess why? Yeah, because we are using a database, so you need the data source, very easy. And I have defined the data source here. You can see I have directly called the bean method, and yeah, it connects to my database here, which is the Spring database. And we need the lookup strategy. The lookup strategy, which was decoupled from the service itself, represent the objects to which the service delegates in order to specify how the entries are taken from the database. So if you go to the lookup service, then this is another bean that I have implemented here, and you can have some other lookup service, but I'm only using the basic lookup strategy here, and usually I did use this basic lookup strategy. And the basic lookup strategy is, again, if you go inside, you will see here it implements the way you take the entries. So you have the select for the entries. So that's the lookup strategy, is the object to which the ACL service delegates in order to take the rules from the ACL entry table. And then for that, it also needs the data source again. That's why the data source is referred also from here. That's not mandatory, of course. You can have some other strategy from where the entries are taken from a web service, for example. So assuming that you want to implement your own objects, you can do whatever implementation you want. But in this case, both the ACL data and the ACL entries are stored in the database. So that's why both objects use a data source. And this is the data source defined by me up there. I have shown you. The ACL service implementation and the default lookup strategy is also using a cache, and the reason for why it's using a cache is because you will have at some point a lot of selects to the same rules, and that means that you would have a dramatically to dramatically affect the performance of your application. So can we do something that you don't have to repeat the same queries and take the same entries again and again? Yes, let's assume we can cache this. And we can cache this. That's a good option here, because you basically will change these rules not that often, and you can have an amount of time on which you simply store the entries in a cache, such that you can take them from the internal memory or from somewhere closer to just selecting them from the database, which usually takes a lot of time because it represents both the networking traffic and the call to the database management system. And you have also the logger, the way you are logging, and in my case I have chosen the cancel audit logger, but again it offers you the possibility, you know, the two columns here, the audit success and the audit failure. That means the logging it does also happen. So in order to be decoupled, the lookup strategy allows you to specify how do you want the logging to be. Usually it won't be in a cancel, isn't it? Usually you will have some kind of a logger that sends your data to an Elasticsearch database, or to Splunk, or something like this, or maybe to a file. I don't know, you want to have some rollout appenders. But in my case it would be just easier to see them in the cancel. That's why I have chosen this cancel. So you have these beans here that you have defined. I have only specified which are the most important in terms of the contracts, because the others are not necessarily related to the contracts. They are implementation related, and they are not that important. So that's why I have here defined the cache, I have defined the data source, I have defined the lookup strategy, which looks in the table of the entries. In my case, I have defined the ACL service, that is the manager of the ACLs, and then delegates to the lookup for the entries. And the lookup then uses the cache as well in order to cache the entries. So this is and the service as well uses the cache. You can see that both of the objects working with the database here, in my case, they are using the cache. So that's why it's very complicated, this configuration, because it has a lot of actors working in for solving this responsibility. But if you take them one by one, usually you can specify, you can say that the most important of the actors are the ACL service, which is the object managing the ACLs, and then you have the lookup strategy, which is managing the entries. You have the cache. I hope you understood why a cache is needed, for performance improvement reasons. And you have the data source, because in my case, in our case here, we really do search in a database, and this implementation, by the way, uses JDBC. It specified that the JDBC is used because this decouples from any kind of other framework. So that's, yeah, a good choice from my point of view. And then you have seen the method security expression handler, and everything is basically through the method security expression handler delivered, because in the end what Spring Security will do is see where methods are annotated with post filter, pre-filter, pre-authorized, or post-authorized. And it will do that again because we did use here somewhere the enable global method security with pre-post enabled. And when it sees a method like that, it interprets here the expression language based on the way we have configured, and that's where everything starts. So everything starts from here, which will basically be interpreted by the expression handler, which knows the ACL service, that knows the lookup strategy, that knows the data source and the caching and the logging. so that's the link, if I manage to make my story from one point to the other. And let's test it now, because in the end this is basically most of it. So we have this application, and we have decided to store products, but we have decided that products are not stored in terms of actions. The security on the products is not in terms of endpoints, is in terms of the objects themselves. So when you have something like this, and in my application here I have even chosen to avoid completely to have any kind of endpoint. You have seen that in both my configuration classes, in neither of them I have overridden the web security configure adapter. So I simply just have chosen to have all the endpoints secured with the default, which is HTTP basic. And I have defined the users, but I didn't apply any rule on the endpoint to make this example as easy as possible, because you can mix them, of course. You can have both security on endpoints and security on methods and security on the model itself using ACLs. But in my case, I assume that I've stored products, and I want each instance of the product to be specifically defined the access to be specifically defined through the entries of the access lists. I have some rules, and I put the rules there in the entries table, and those are the rules that specify the access to my objects. So if I run now the application, let's run the application, and then we will use the postman to call our one and only endpoint that takes all the objects. So we go here, and I call the endpoint using John and 1, 2, 3, 4, 5. Then what you will see is in the response, the only object that I receive is the chocolate. And what you will notice is that beside the fact that we have two objects, and you might think is find the method who did the filter here. No, find did return everything correctly, like all the products in my case, but then the aspect of Spring, it is an aspect of Spring just behind, interpreted the expression in the post filter annotation and made sure that I will not receive anything for which I don't have the right permission, because this is the way the expression was specified. So this is, please do return only the objects for which the user has the right permission. And again, here the right permission is not granted for object 1, which is the beer. So that's why we only receive, going back, we only receive the chocolate. So what we receive the second object, which is the one for which the right permission is granted. If I call it with the bill, then bill will not even receive any of the products, because I have no bill in my access list. So if the user is unknown, then nothing will apply to it. Oh, and by the way, if you go to the console, because that's why we have added a console logger. Where is the console? Somewhere here. Okay, this is what was logged. These two lines that are telling me when I have called the endpoint for John, and you see the principal John here, I had two entries related to the object. One of them was denied, which is the chocolate, and the other one was granted. Denied, which is the beer. The other one was granted, which is the chocolate, the one that we have seen. So because of that, only what was granted to the user went to in the response that we have seen in Postman. Because you see that I have already two lines for only my call in this case, this I think makes also more clear why I need to always put this usually on false and then only activate them for when I really need them to be there. So this is basically how the ACLs work. I hope I managed to explain you the big picture of it. I will put this project as well on the GitHub, so you can take it yourself and you can implement it and see how it is working. It's not that difficult. It is complex in terms of configuration. It is complex not only in terms of configuration in the application, but also in the maintenance as well. So from my point of view, if you don't explicitly need this in your application, avoid it. In a lot of applications, the endpoint security, or at most the method level security, is more than enough. The domain level security is very granular, offers you a lot of power in terms of restrictions, but it's also heavier to configure, heavier to maintain, and at the same time it adds a lot of complexity, and the performance is as well affected of your application, because you can already imagine that all the time now you use an object, it will try to match every time there is a pre-post method. In my case, it will try to manage the objects that are received as parameters, objects that are returned, and so on. So it's a lot of operations happening there now. That's also why a cache was added, so you don't have to work with the database all the time. It's a good thing, but it still adds a lot of operations which affects the performance. So it's a great tool. With great power comes great responsibility, said Uncle Ben. You have to be careful with that. If you really need it, use it. It's working fine. You don't have to redo it yourself, like create your own implementation if this fits you. But if you can avoid it and your endpoint security or method level security is enough, then avoid it and use only what's the minimum needed for your application level security. Okay, thank you very much for watching this video. I hope this is helpful. I wait for other questions and see you. Stay tuned for next videos.